You're standing in open grassland in East Africa, 315,000 years ago. The air smells like dry earth and blood. Something died nearby, something large. You didn't kill it. The cats did. You can hear them now. Low rumbles through the acacia scrub, maybe 40 meters away. You weigh around 130 pounds. The cave lions circling that carcass weigh 700. You have a sharpened rock in one hand and 4 people behind you. That's it. No walls. No weapons with range. No rescue. And somewhere behind you, the children are waiting. Right now, you're reading this in a building that protects you from weather, predators, and strangers. You haven't once today had to wonder whether something was going to eat you. But for most of our species' existence, that was the actual question every single morning. So how did early humans survive long enough to become the dominant species on Earth when every ecological advantage was stacked against them? The first answer almost everyone reaches for is the brain. And they're not wrong, but they're not as right as they think. In 2017, paleoanthropologist Jean-Jacques Hublin and his team at the Max Planck Institute for Evolutionary Anthropology in Leipzig published findings from the Jebel Irhoud site in Morocco, a site that pushed the origins of anatomically modern Homo sapiens back to at least 315,000 years ago, roughly 100,000 years earlier than previously accepted. The skulls they found had faces almost identical to yours, but the brain case, the part housing higher cognitive function, was still elongating, still evolving. These were modern humans in the making, not finished products. That's not a footnote. It's a crack in the big brain, saved us theory. Because if the brain was still developing, while humans were already surviving brutal megafauna, collapsing climates, and competing hominin species, then raw intelligence wasn't the whole story. The hard number that makes this land, those Jebel Irhoud fossils, are 100,000 years older than the oldest previously accepted Homo sapiens remains. For a full 100,000 years, humans were surviving, before the brain finished becoming what we now consider modern. Something else was keeping them alive. Here's where it gets strange. Everyone assumes that ancient humans survived despite being physically weak compared to their predators. The truth is that human endurance physiology is one of the most extreme athletic adaptations on the planet, and most people alive today have never once used it. Evolutionary biologist Daniel Lieberman at Harvard University has spent decades studying human running mechanics. His research, summarized in his 2004 paper in the journal Nature Co., authored with Dennis Bramble, argues that Homo sapiens evolved specifically for persistence hunting, the practice of chasing prey across open ground for hours, sometimes days, until it collapses from hyperthermia. A human can run a marathon at a pace that would kill a horse in the same heat. The human body has around 2 to 4 million eccrine sweat glands, more than any other mammal on Earth. A zebra, by contrast, pants in midday African heat above 30 C. The zebra has to stop. The human doesn't. The cheetah hits 70 miles per hour, humans top out around 12. But the cheetah can sustain that speed for roughly 30 seconds before overheating. Humans can sustain moderate pace for hours. Ancient humans weren't prey who got lucky. They were endurance weapons, operating in the one environment where their physiology had no peer. They didn't outrun predators. They outlasted everything. But the body alone doesn't explain it. So what else was at work? In 2020, researchers studying the Pinnacle Point cave site in South Africa, a site that preserves evidence of human behavior going back 164,000 years, found something that rewrote assumptions about how early humans survived climate collapse. Around 195,000 years ago, a severe ice age drove Homo sapiens populations to near extinction. Genetic bottleneck evidence suggests the global human population may have dropped to as few as 10,000 individuals, roughly the population of a small town. Some estimates go lower, to 2,000 breeding individuals. The species did not go extinct. The people at Pinnacle Point survived by doing something that no prior hominin species had done at the same scale. They shifted their entire diet to shellfish and coastal resources, exploiting a food niche that stayed productive even as inland environments became uninhabitable. They also demonstrated early evidence of ochre processing and symbolic thinking, signs of cultural information storage that could pass survival knowledge from one generation to the next. The gap between surviving and not wasn't physical. It was behavioral flexibility, the ability to do something new when the old way stopped working. And that flexibility, the record shows, already existed 195,000 years ago. So why didn't the smarter hominins survive too? Everyone assumes Homo sapiens won the evolutionary competition because they were the cleverest species. The truth is, they weren't, or at least, there's no evidence that raw intelligence separated them from Neanderthals, who had slightly larger average brain volumes and demonstrably made jewelry, buried their dead, and used ochre. What the fossil and genetic record actually shows is that Neanderthals survived in Europe for roughly 400,000 years, an almost incomprehensible run, before Homo sapiens arrived, and within 5,000 to 10,000 years, Neanderthals were gone. Paleogeneticist Svante Pääbo, who received the Nobel Prize in Physiology or Medicine in 2022 for his work on ancient DNA at the Max Planck Institute in Leipzig, published sequencing of the Neanderthal genome that showed something nobody expected: modern humans and Neanderthals interbred. People of non-African descent today carry roughly 1 to 4% Neanderthal DNA. This isn't a footnote about genetics. It means Neanderthals didn't simply disappear, they were partially absorbed. The two species were in contact long enough to produce viable offspring. What Homo sapiens had wasn't necessarily a smarter brain. It was a larger network. Archaeological evidence shows Homo sapiens trading shells and pigments across distances of 300 kilometers or more during the same period. Neanderthal exchange networks appear to have been far more localized, rarely extending beyond 80 kilometers. When climate stress hit, a species with a 300-kilometer information and resource network could adapt. A species working within 80 kilometers could not. Here's the synthesis. And it's uncomfortable if you've spent any time congratulating yourself on how much smarter modern civilization has made humanity. The specific traits that kept early humans alive: endurance, behavioral flexibility, and wide social networks that spread information across distance are not traits that modern life selects for or rewards. The body that evolved to chase prey for 6 hours across open savanna now sits in a chair for 8. The social network that once connected scattered bands of humans across hundreds of miles is now largely mediated by screens and strangers. The behavioral flexibility that allowed humans to survive a climate collapse by reinventing their entire diet is now used mostly to switch streaming services. This is not nostalgia. Ancient life was brutal in ways that most modern humans would not survive a single week of, but something was built into the human animal over those 315,000 years: a deep, structural resilience that lived not in individual genius, but in the space between people. Back to that grassland. Back to the 130-pound figure with a sharpened rock, 4 people behind them, and children waiting. The reason that person survived has almost nothing to do with being the strongest animal in that landscape, and almost everything to do with the 4 people standing at their back. People who shared information, shared food from distant coasts, shared cultural knowledge encoded in ochre marks on cave walls, and could run through midday heat when everything else had to stop. The ancient humans didn't go extinct because they had each other in a way that made the sum genuinely, measurably different from the parts. The species that looked the weakest on paper built a network strong enough to outlast every predator, every climate, and every competing lineage. We didn't survive because we were exceptional individuals. We survived because we were an exceptional species, and the difference is not a small one.